This session is about algorithm analysis. So let's look into what is algorithm analysis. Now we have learned about algorithms and what is an algorithm and all. Now let's see what is algorithm analysis. So if we just refresh our knowledge, algorithm is a clearly specified finite set of instructions a computer must follow to solve a problem. It's a finite set of instructions a computer must follow to solve a problem. Algorithm analysis. It's a process of determining the amount of time, resources, etc. required when executing an algorithm. So algorithm analysis, it's a process of determining the amount of time, resources, etc. required when executing an algorithm. Simply, it's a process of determining the amount of time, resources, and things like that. Now, why algorithm analysis? So, writing a working program is not good enough. So, we have an idea about the efficiency now. So, writing a working program is not good enough. The program may be inefficient. If the program is run on a large dataset, then the running time becomes an issue. Now, your program might work for a small dataset or for a test scenario, but when it goes for the real time, when there's a large dataset, your program might fail. There will be performance issues, performance bottlenecks. So we need algorithm analysis, because writing a program is not good enough. The program may be inefficient. If the program is run on a large dataset, then the running time becomes an issue. So algorithmic efficiency explained in a nutshell. So if we want to compare two algorithms, we could say algorithm A is twice as fast as algorithm B. But in fact, this sort of statement is not meaningful. So you might ask, why not? So when you're comparing, you might say, no, if algorithm A is there, algorithm B is there. So when you're comparing, algorithm A is twice as fast as algorithm B. But that statement is not meaningful. Let's see how. Because the proportion can change radically as the number of items changes. So number of items can change. So let's see how it goes. Perhaps you increase the number of items by 50%. So if it's a sorting algorithm, if you increase the number by 50%, and now the algorithm A is 3 times fast as B, or you have half as many items, now you might see A and B are now equal, almost equal. So if your data set, if you increase the data set, so situation A, you might feel, random situation, algorithm A is twice as fast as algorithm B. If you increase the data items, the data set by 50%, now you might feel, now algorithm A is 3 times fast as B. Or if you have half as items, if you take half of the items, if you reduce the number of items, now you might get the results that A and B are almost equal. Now you understand that the comparison, when comparing, it tells how an algorithm's speed is related to number of items. You need a comparison that tells how an algorithm speed is related to number of items. If you just say algorithm A is twice as fast as B, or algorithm C is 3 times fast as algorithm B, but that's not meaningful. What you need is a comparison that tells how an algorithm speed is related to number of items. So the number of items play an important role. So what you need is a comparison in order to make it meaningful, which tells how an algorithm speed is related to the number of items. So algorithm analysis important. The first point is we only analyze correct algorithms. If the algorithm is wrong, no point talking about the efficiency. An algorithm is correct if for every input instance it holds with the correct output. Incorrect algorithms might not hold at all on some inputs instances. So we don't consider incorrect algorithms. Analyzing an algorithm. Predicting the resources that the algorithm requires. Resources include things such as memory, computational time. So if we talk about the running time, most algorithms transform input objects to output objects. The task of an algorithm is to transform input objects into output objects. The running time of an algorithm typically grows with the input size. The running time of an algorithm increases when the input size is increased. So average case time is often difficult to determine. So we focus on the worst case or the upper bound running time. It's easier to analyze. Crucial to applications such as games, finance and robotics, and occurs more often. From the graph you can see the worst case take more time, the best case, the happy day scenario, takes less time, and we take the average as the average case. So the x-axis is input size, y-axis is running time. So if you carefully analyze this chart, you can see best case, average case and worst case. So the best case is the always better one, but it won't happen. So we focus on the worst case. So if the algorithm can survive in the worst case, then that's good. Worst case running time of an algorithm. The longest running time for any input size of n. An upper bound on the running time for any input guarantee that the algorithm will never take longer. The worst case, if you analyze the worst case, that's the worst case as the word suggests. So it guarantees that the algorithm will never take any longer than that. So the maximum time is the worst case. For example, sort a set of numbers in increasing order and the data is in decreasing order. The worst case can occur fairly often in searching a database for a particular piece of information. So if you want to sort a set of numbers in the increasing order and the data is in decreasing order, so that's the worst case. Best case is sort a set of numbers in the increasing order and the data is already in the increasing order, so there's not much work. So that's the best case. Average case running time, maybe it's difficult to define what average means, but average is we take the time in between. And we can do experimental studies as well. Write a program, implementing the algorithm, run the program with inputs and varying the size of comparison, use the method to get an accurate measure of the running time and plot the results just like this: input size in x-axis and time taken in y-axis. Limitations of experiments. So there are limitations as well. For this to be done, we need to implement the algorithm, which may be difficult. And also the results may not be indicative of the running time on other inputs not included in the experiment. So we cannot have all the inputs in the world, but results may not be indicative of the running time of other inputs. And in order to compare two algorithms, the same hardware and same software requirements must be used. So these are the limitations of experiments. The main thing is it's necessary to implement the algorithm, and which can be difficult. And we can't test with all the inputs. Therefore, the results may not be indicative of the running time on other inputs not included in the experiment. And we should have same hardware and software requirements in order to compare two algorithms. Running time. So factors affecting the running time. So if we list the factors, one is the computer, next the compiler, then the algorithm used, and also the input. The content of the input affects the running time. Typically, the input size, number of items in the input, is the main consideration. Sorting problem, the number of items to be sorted. So if you are sorting two numbers, it's easy. If you are sorting millions of numbers, then you can understand it takes time. Machine model assumed, instructions are executed one after the other with no concurrent operations, no parallel computers. So there are different approaches. Empirical. Run an implemented system on real world data, notion of benchmark. Simulation. Run an implemented system on simulated data. Analytical. Use theoretic model data with a theoretical model system. So these are the different approaches. Empirical, that means run an implemented system on real world data. Simulation, run an implemented system on simulated data. So simulation is not on real data, it's on simulated data. Analytical, use theoretic model with a theoretical model system. So those are the ways. So in this session, so we talked about algorithm analysis. I am Achala Aponsu presenting here. What is algorithm analysis? We discussed about what is algorithm analysis. It's a process of determining the amount of time, resource, etc. required when executing an algorithm. Then we looked into the situation of why we need algorithm analysis. Then we came to know that writing a working program is not good enough. The program may be inefficient. And if the program is run on large data set, then the running time becomes an issue. Next, we discussed about algorithmic efficiency explained in a nutshell. So if we are telling algorithm A is twice as fast as algorithm B, we understood that that sort of a statement is not that meaningful. Why not? The proportion can change radically as the number of items changes. So if the data set is changing, the size of the data set is changing, we can't always tell algorithm A is always twice as fast as algorithm B. So what we need is a comparison that tells how an algorithm speed is related to number of items. How the algorithm speed changes from number of items. How can we explain that? We need a comparison like that. Therefore, we are going to use algorithm analysis. And before talking about the efficiency, we got to know that algorithm should be correct. We only analyze correct algorithms. Next we discussed about the running time, the best case, average case, worst case. Worst case running time of an algorithm is the longest running time for any input size. So it guarantees that the algorithm will never take longer than that. Best case running time, sort a set of numbers in the increasing order and the data is already sorted, job already done. That's the best case. Average case in between. So when we discussed about experimental studies, limitations of experiments, you got to know that it is necessary to implement the algorithm, which may be difficult. Results may not be indicative of the running time of other inputs not included in the experiment. And in order to compare two algorithms, the same hardware and software must be used. So next we discussed about the factors affecting the running time: computer, compiler, algorithm, and input to the algorithm. Next we discussed about the different approaches: empirical, simulation, and analytical. That's the end of the session.